Okay, chemistry. So this is a quick lesson over elements and symbols and what the periodic table looks like. So here is oxygen, and we have like my drawn cutout of the periodic table, and I've tried to color code it for you. So you have the O in the middle. This is the symbol for oxygen. Then you have the name underneath. Up at the top, this is our atomic number. And then down at the bottom is the atomic mass. So that's all the parts. So that's the different things. How we identify elements is by their atomic number. So the atomic number is equal to the number of protons that they have inside of their nucleus. And that number is specific to each element. If it has one proton, if you have an atom with only one proton, it is always hydrogen. That's how we identify hydrogen. That is the defining characteristic of hydrogen. If it has two, it's helium every single time. Two protons, helium. Three protons would always be lithium. So atomic number for hydrogen is 1. It's the first one on the periodic table. Second one's helium. Third one's lithium. Fourth one's beryllium. Beryllium has 4 protons. So hopefully that's kind of making sense. So it's the number of protons on there, and they're listed in order by their atomic number / their number of protons. So atoms in general are electrically neutral. And so that means that the positive charge cancels out the negative charge. If something's neutral, it's not one way or the other. So it doesn't have a charge. It's not positive, it's not negative. So protons are positively charged. So if oxygen has 8 protons and I need it to be electrically neutral, that means it has to have 8 electrons to cancel out. So the number that varies for a element, the particles, it's their neutrons. And they can have different number of neutrons, and that makes them an isotope. The exact definition of an isotope are atoms of the same element but that have different number of neutrons in the nucleus. So an isotope is going to have all of the same properties. So isotopes of the same elements have the same chemical properties. So however hydrogen reacts, it's always going to react that way. It's going to have the same chemical properties, whether or not it's what type of isotope it is. So I like to use carbon for an isotope to kind of show what I'm talking about. So if you look at your periodic table, carbon is number 6 on there. So its atomic number is 6. So that means it has 6 protons. And if it's electrically neutral, it also has 6 electrons. So I abbreviated electrons for you there. So there is a carbon that has a mass number of 12. There's a carbon 13, and there is a carbon 14, and I ran out of room, so I did C14 for the last one. Okay, so it always has 6 protons. So all of these have 6 protons. Now then, that number beside it is called the mass number. This number right here is the mass number. And how we calculate the mass number is just protons plus neutrons. So we're adding up everything so mass number is equal to protons plus neutrons. So we're just adding up everything inside of the center, inside of the nucleus. We don't care about electrons. We care about protons and neutrons because they weigh a significant amount more than electrons. So if I have 6 protons, which this is a plus sign, not a T, and I want to get to 12, that means I also need 6 neutrons. So 6 protons plus 6 neutrons is 12. For carbon 13, I would need 7 neutrons because 6 plus 7 is 13. And so that means for 14, I would need 8 neutrons. So they're all carbon. They all have 6 protons, which is the defining factor for carbon. They have different number of neutrons, but they're still going to react the same. It's still carbon. So whenever I put carbon in something, it's going to react the same way. It doesn't matter that it's a different isotope of it. So this mass number right here, this carbon 12, carbon 13, carbon 14 is not the same thing that's on your periodic table. That's something called average atomic mass, which we're going to learn how to calculate in the next video.